Okay, our next chapter is sampling distribution, which is chapter 7 in your book. In this chapter, we will study the concept of sampling distribution. We will compute the probabilities related to sample mean and sample proportions. What is sampling distribution? Sampling distribution means that if you want to study a population could be number of people, population could be number of items, number of chairs, it could be a number of computers. You want to test their quality, then we take a sample out of this. So population doesn't mean number of people here. So for example, here it says the sampling distribution is a distribution of all possible values of sample statistics given sample size. So let's say we consider a population of China. We denote it by capital N, 1.3 billion. So we always denote population with capital N. Then we take a sample out of this population to test something. Let's say we want to see how many people are infected with the, let's say, coronavirus. So we take a sample of, let's say, 10,000 people. So we always denote small n with sample size and capital N with the population size, and this is our sample size. So we can take different samples. We can take sample from Shanghai, we can take sample from Wuhan, we can take sample from Hangzhou. So every sample will give us a different result. So that is what he says in the second point. For example, you select a sample of 50 students from your college. Now in college there must be in thousands, let's say 10,000 students are studying in your college. You take a sample of 50 students from your college regarding their mean GPA. If you obtain many different samples, you take sample from Yan'an campus, you take sample from Songjian campus, their mean GPA will be different. So similarly, if you keep changing the samples, their mean GPA will be different. Now to do the example, we consider a small population, because if I consider population of China and sample size of 10,000, then there would be many samples. We cannot tackle them in a simple example. So for instance, we consider a population of 4 people, and we take a sample size. We take sample of 2 people out of whole population. We take sample 2, and we want to see that how many possible samples we can draw. So all possible samples could be n raised to power n. So 4 raised to power 2 is 16. So this is how we can draw all possible samples. This is with replacement. Later we will see without replacement how to see all possible samples. So there would be 16 all possible samples. Now before doing this, we draw the mean and standard deviation of our population. Our population size is 4. What is that? There are 4 people with different ages, 20, 22, 18 and 24. We calculate their mean. So their mean is 21. We denote it by this Greek letter mu. We call it mu and we read it mean. So this is sigma, standard deviation of these 4 people. So their standard deviation is 2.236. Now we calculate all 16 samples. How do we calculate all 16 samples? We write here our whole population in a row, and here we write whole population in a vertical column. So we try to draw how many samples can be drawn out of this population with size 4. 18, 18, 18, 20, 18, 22, 18, 24. We write it here. Then we move to the next number, 2018, 2020, 2022, 22, 24. Then we move to the last one, 24, 24, 18, 24, 20, 24, 22 and 24, 24. Now after doing this, these are 16 possible samples with replacement. You can see here it is written with replacement. Later we will discuss how to do for without replacement. Okay, next we calculate their means. So here you can see 18 plus 18 divided by 2 is 18. We write their mean here in their respective column. 18 plus 20 divided by 2 is 19. 18 plus 22, 18 plus 22 divided by 2 is 20. We write it here in their respective place. 18 plus 24, 18 plus 24 divided by 2 is 21. We write it here. Similarly, up till here, 24 plus 24, 24 plus 24 divided by 2 is 24. So we write it here. So in this way we write their all means. Now we calculate mean of their means. Since these are all means, now we add all these numbers and then divide it by 16. It will give us, you can see, these are all means. Now we add all these means, we add them up and we divide them by 16 because they are 16. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Divide them by 16, it will give us mean of mean. Here you can see that we denote it mean of means. So this is also a notation of mean which you already know. So it is 21. Now we calculate the standard deviation of these means. So standard deviation of these means is this. So the formula of standard deviation of mean will become sum of means minus their means whole square divided by n or n minus 2, whatever you think. Here he is using n, so it is n. Okay, next you see mean of sample mean is 21 and mean of our population is 21. Standard deviation of our population of 4 people is this. Standard deviation of mean is 1.58. If we consider all possible samples, then these two should have a relation. What is that relation? That standard deviation of means is equals to standard deviation of population divided by square root of n. So let's see how it works. So you can see this is the formula which I just mentioned, that sample mean, sampling distribution, standard error of the mean. We also call it standard error of the mean. Why we do calculate this? Different samples of the sample size from the same population will yield different sample means. A measure of the variability, because every sample is giving us a different sample mean. So to measure this variability, the sample we use standard error of the mean. So this is the formula of standard error of the mean, and it will evaluate or it will eliminate this variability and it will become equal. You can see it here. This is the formula, that sigma x bar equals to sigma over square root of n, and this is always equal. And here you can see it was you can verify it. You can substitute their values here, and you can see it will become equal, and this was already equal, 21 and 21.